I wasn't sure about that as a developer, as an IT manager, because things are running inside my code and actually using up my application resources. They might jam my application, they might stall it, they might bottleneck it. We got used to that being okay.
This is DevOps Paradox, episode number 178, Kubernetes Observability Using eBPF. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. In the world of observability, we keep on hearing about this thing called eBPF. And I've tried doing some research on it, and I think, man, this sounds like all sorts of new hotness. And I do my research, and BPF goes back 30 years. Victor, were you still in diapers then?
I wasn't in diapers back then, but I was very young. But what you're just saying for BPF basically applies to almost everything, right? It takes time until some obscure type of technology becomes mainstream. Containers are probably just as old as eBPF.
Probably older, that's right. So on today's show, we have Shachar Azulay on from groundcover. How are you doing, Shachar?
I'm doing great. Thanks for having me.
Now, do me a favor and say your name correctly because I completely butchered it twice.
Shachar Azulay, that's the name in Hebrew, but you got it perfect in English.
Okay. Thank you. So groundcover are some of the new kids on the APM block. And they're using eBPF like all the cool kids are today, but for Kubernetes. When I've heard eBPF talked about a lot in an observability context, it's like, oh, let's put it on our Linux kernel, or even to a point, there are some eBPF options available for Windows. But Kubernetes, really?
So I mean, it's an interesting story for eBPF. I guess we can start from there because eBPF has been around for a while, as you guys said, for almost 30 years. But I agree with Victor that great technologies take time to both evolve and also fit their current environment and their needs of the market and the people in the market. BPF started up really early as some kind of a mechanism for filtering packets and kind of getting probes into high throughput networks and figuring out what's going on. But it was the start of eBPF in a sense that it was already a virtual machine running in the kernel. eBPF since 2014, when kind of Kubernetes was born the same year. So it's an interesting kind of anecdote around the birth of eBPF, the extended version of BPF. But basically it allows people to do very interesting stuff inside the Linux kernel. It's a need that has been going on for years back. I mean, people used to write kernel modules to kind of customize their need in high performance monitoring, security, and things like that. eBPF opens up new use cases. So Kubernetes is just an environment where there's a need to do things differently, and working in the kernel space can open up a lot of new use cases. But I guess the technology behind it took a lot of time to reach a point where it can actually perform and do stuff that developers and SRE teams and DevOps teams actually need.
Given that it works on a kernel level, does that mean that eBPF is only useful for those who have access to kernel? Like self-managed, but not cloud?
So I guess that's exactly the kind of the involvement behind eBPF, because before, if you had to do something very specific in the kernel, like, for example, I want to write DDoS prevention mechanism inside the kernel, or load balancing in high throughputs inside the kernel, things like that, I used to have to either write a kernel module and say, okay, I'm taking the risk of changing the behaviors of the kernel. I'm going to recompile the kernel with a kernel module that I just wrote. Clearly, it's a risk in production, but people used to do it in different examples along the years. And the other part you can take, and I guess that's kind of what you're referring to, is can I influence the kernel community? Can I have access to the kernel, write to the kernel, and kind of change the behaviors and insert more features into the kernel? eBPF creates a full abstraction from that. So you're not dependent, one, on the development cycles of the kernel, which take years, between an ID pitched to the community, which is really close community managed in a very strict way, until it kind of reaches the distributions that all of us use as developers. And you get all the benefits of a virtual machine that make sure your code, your eBPF program is verified, secure, safe in production. And you actually use kind of an API experience of loading your program into the kernel without actually having access to the kernel, changing the behavior, actually using primitives that a virtual machine allows you to do. So you don't have to be a kernel developer. You don't have to know exactly what's going on. You have to know what you want to achieve from an application level, more than, from a kernel perspective of what's actually going under the hood.
So in studying a little bit about eBPF, or trying to at least get my head around it, it's basically a little program, I'm going to air quote program, that's either C or Rust. And I want to go back to what Victor was just saying, they're running in the cloud. Could I actually use an eBPF program with a fully managed Kubernetes solution such as Civo or GKE or even to a point EKS?
Yeah, so basically, as you say, all the way down to the core of what eBPF actually is. eBPF is a virtual machine inside the kernel that eventually writes and executes eBPF bytecode. Eventually, there's even another component inside eBPF which takes care of just-in-time compiling, of actually converting, in most cases, this bytecode to actual machine code. So you're actually running in the kernel directly on the CPU, as you would like to get to usually do in high-performance cases. So you get all the benefits of that. But basically, on top of that, there's system calls that were designed, and you can access them in different libraries and eventually load your BPF program into the kernel. So from a perspective of a developer, basically what you're doing is you're writing a BPF code, usually in C or Rust, as you say, use a compiler to compile it and eventually load this bytecode into the kernel. On top of that, that's where you can use Kubernetes primitives to actually work and create something that could be a deployment in Kubernetes. So for example, what groundcover does and other companies, as you say, on the new kids on the block from perspective of security or monitoring, basically, for example, we use a daemon set primitive of actually loading tiny BPF program, as you might call it, on all the different nodes inside the cluster at once. So the experience is I'm deploying something which I know, a primitive which I know, like a daemon set on Kubernetes. Eventually what it does, it communicates with the kernel of each of the machines, loading my BPF code and running the monitoring program that I designed. You're able to move between the different ends of the stack, between the Kubernetes deployments you're familiar with as a cloud engineer, and the kernel program eventually executing the kernel on the machine pretty easily. And I think that's kind of what opens the really interesting use cases you guys are referring to, because it wasn't that easy at the beginning, certainly not in the BPF era. And currently doing it on an entire cluster in Kubernetes opens up really new ideas of what I can do to monitor an entire cluster.
You just said BPF era. Can you explain what's the BPF versus eBPF?
So BPF was kind of the preview of what eBPF is now today, in a sense that BPF is a virtual machine, in a sense. Eventually BPF back then already executed a bytecode which was fitted for the BPF virtual machine, but it was very limited in a sense that it was designed to execute predefined filters on packets to do specific network operations. We see it, for example, in TCP dump, which is eventually executed inside the kernel, inside this virtual machine. So eventually, when you activate TCP dump, which is something most developers have engaged with at some point, there's eventually translating your query inside TCP dump to actually figure out what you're trying to do and what you're trying to filter. But eventually, it translates into a bytecode running in the kernel that performs this filter. So The differences are what can I do? And I think one of the major leaps inside from BPF to eBPF was, can I just execute a set of pre-selected operations which I can eventually execute, and can I do more complex stuff? For example, eBPF introduced the idea of maps, which are actually data structures between the user space and the kernel space. So it means that my BPF program suddenly can have a state. I can hold on to a state, share it between different BPF programs, running different eBPF hooks on the kernel, and even share it with the user space. So for example, if I'm writing a firewall using eBPF, I might want to update once in a while from the user space, the exact firewall rules that I want to execute inside the kernel. I can do that. I have a way to move data around between the different, between the user space and the kernel space. That, together with a new verifier that eventually secures the deployment and allows me to run complex logics without, being afraid that it will cause anything to the kernel, that opens up, the complexity of the program that I'm running, basically, and what I can do with it. So basically, you can do a lot of different stuff today, which are actually business logics that you would used to do in the user space. You can kind of propagate them more easily into the kernel space, and that wasn't available back then when BPF just started.
Correct me if I'm wrong. From my perspective, eBPF gives us the ability to do certain things on a different level than what we might be used to doing. But is there also, from practical perspective, certain things that, not how we do things, but that we can do things that we couldn't do before? Like, why would I, let's say that I'm a Kubernetes user, why would I use something eBPF instead of whatever else I was doing in the past?
eBPF is kind of working on these two major differences, as you say. One is that I can do things differently, the same things I can do very differently. If we take it to the perspective of monitoring, for example, then we can monitor from the kernel space all of the user space. It opens up a new way of doing monitoring, because it's not that I couldn't have monitored the user space before. I used to integrate an SDK into my code, which I used to have running inline inside my application, doing the monitoring for me, and then I had to eventually integrate that SDK into any one of the containers or the applications running on top of the kernel. It could be Python, Java, whatever I used to deploy, and then I had to solve it for each. Now one agent running inside the kernel can basically monitor all of these. So it opens up new use cases there, but it also opens up new data sources which weren't available before. One of them, for example, is things that certain communications that are harder to eventually get from instrumentation inside the application. For example, things like DNS. We monitor, for example, in groundcover DNS. These are kind of infrastructure related protocols, the layer that you're usually you cannot easily achieve visibility into from the application layer. And the other one is kind of the relations all the way to the actual infrastructure. We see a lot of insecurity solutions using eBPF. What modules are actually loaded and running currently? Who is accessing the disk? Things which are really, really deep inside the infrastructure. You can do that from the kernel. If you would have instrumented a user space application, some of these were not accessible, and you wouldn't have been able to connect, application level information to kind of kernel level infrastructure information. Connecting these dots is something eBPF can do really interestingly. I guess that's a major difference.
Did I get it right if I would say that there are certain things that we could do in the past, but we would need to explicitly define them or expose them, some kind of metrics or something like that, and now we do not need to. I do not need to say, hey, kind of like, this is the metric for you. I'm creating that metric. I'm exposing it. You can just kind of fetch it yourself because you're operating on a different level.
Exactly. I mean, from an APM observability perspective, that's really clear. I mean, I had to integrate an SDK that would eventually instrument most of the known libraries. For example, my client, my HTTP client, that eventually performs the networking on the HTTP level, and from there it could have gotten the information of APIs flowing between different microservices. With eBPF, you can catch it from the network layer, from the application layer, using various hooks and like observability probes that eventually eBPF kind of allows. So you can cover all that without having the user or the developer in that case taking care of that. So from like an observability perspective of a team, a team working with many different technologies, with many different developer teams, suddenly you can kind of align the observability stack instantly by just saying, okay, whatever you guys are doing on top in the application, I can get these metrics, these golden signals of say, API latency, throughput, error rates, stuff like that, which you really need for observability. I can get it independent of the application, independent of the R&D efforts, independent of maintenance, basically, of did they remember to instrument that new service. And that's kind of an alignment which crosses an R&D organization in a different way from what we're used to seeing. And yeah, that opens up new ways to monitor deeply without, eventually touching the application all the time and maintaining code in the application.
That alleviates one of the huge pains I had myself in the past. To be honest, I always hated, you start a new application. Initially, you don't think about those things, and then going back and starting instrumentation of everything I have was always, I won't say impossible, but annoying, let's say.
The funny thing about it is that it kind of feels like it's going backwards. I mean, even because, in the golden age of Java, it made more sense. Kind of, eventually there were more ways to auto-instrument the code since Java is such a, virtual machine-based language. But as you go into modern languages, which are current, really, really, actually frequent, you see them frequently in Kubernetes like Go and Rust. I mean, it's practically impossible. It becomes manual labor. You have to instrument so much in your code to kind of reach the same observability level. And we feel the pain from teams all across industries, exactly the pain that you described.
So what are then the major use cases you were mentioning are around security and observability? Are there any other kind of interesting use cases that we are seeing with eBPF, or that's the major effort?
So we're seeing eBPF going to all the networking application like high performance load balancing, things like that. Security, as you mentioned, the workload security is really heavily affected by eBPF. Eventually, the ability to monitor really deep things happening inside the application and the usage of resources. eBPF is really intense there. And observability, I mean, that has many different flavors, from like API observability all the way to profiling, which is kind of even a deeper level of observability. So we see it kind of taking place all across the stack. Cloud providers are also pushing it in very interesting ways. For example, service meshes, projects like Cilium, which kind of say, okay, Istio and service meshes, which were basically based on sidecars and proxies. Let's move them into a different layer running inside eBPF. So basically, we see a lot of different stuff from network to full stack observability all the way to the application happening in eBPF. It's really interesting. I mean, when we started about a year and a half ago, it was much less known, and it feels like it's really blowing up and getting a lot of traction. So it's fun to see from the side how many interest this technology can kind of raise with people. So that's great.
Are there any specific requirements to use eBPF based solution? I remember a few years ago when it was starting, I had to have my own cluster, self-managed cluster, Kubernetes cluster, let's say, right? Now I'm seeing more and more solutions that, hey, this works in GKE, this works with DKS, IKS, whatever, right? Does that mean that it evolved? Or, I mean, why were those needs or restrictions lifted, if they were lifted in the first place?
So there are two things around restrictions. One is basically the kernel version. So most interesting things, started to happen in the last 5 years or so, since 2017. There's been a major improvement. So a lot of solutions today using eBPF for security or observability would kind of need part of the advancements that happened in the past years. So if you, for example, go into an EC2 load, which is not governed, by GKE or EKS, and them pushing kernel versions forward, then you might have encountered lower kernel versions. That's one. But with combining that with Kubernetes, GKE, EKS are pushing high-end kernel versions all the time in their Kubernetes distributions. So, for example, we don't encounter that too much. And the other is the deployment part. eBPF eventually requires privileged container to actually access the eBPF program. That's also something that the community is working on, but that's the default capabilities, for example, in GKE, EKS, and many other providers. So you don't have to do anything. I mean, a lot of different agents currently run by DevOps teams actually use that same capability. So bottom line, nothing actually special. I mean, if you're using Kubernetes in a reasonable version, you probably have kernel versions that fit, and you can just run it on any flavor of Kubernetes. Clearly, the top managed tiers of Kubernetes that we all know.
If I understood right, we are already reaching the stage where eBPF becomes an implementation detail. For me as a user, I just want a solution that does X. It happens to use eBPF in a background, but for me, it's just yet another application, another third-party app that I'm running in my cluster, just like anything else.
I couldn't agree more. I think that's what we're trying to also say in groundcover. I think eBPF is still really raw. I mean, clearly it's not accessible to the average developer, and we're part of the community. I mean, in groundcover, we're part of the community of that pushes eBPF forward as an open source solution for many developers. But we believe that in 2 or 3 years, one, it's going to get there in a sense that, like other technologies, as a developer, you wouldn't have to, hear the best podcast about what is eBPF to use eBPF. There's going to be a lot of solutions already, starting that wrap eBPF in a sense that you feel that it's another, application or toolbox that you can just use to get things done. It's definitely getting there. I mean, for example, in our product, which is focused on APM, you wouldn't have known there's the eBPF running underneath if we wouldn't have told you. And that's the experience that a lot of different, vendors eventually try to reach there. Do what you can do with eBPF to get the data that otherwise would have required so much manual work from the R&D team, but then kind of obfuscate it as a technology from the developers, because it's not that everybody has to know exactly how things work to get all the benefits. And there's a lot of really cool tools around that also in the open source domain, like BCC, for example, which is an amazing library. So as a developer, probably in a year or two, you're going to be using more and more eBPF tools without actually knowing what's happening underneath, and without actually, being sure what part of the solution is based on eBPF and what part of it is not. And I think that's a great milestone to reach for the community.
How do we help directors of IT figure out, the warm and fuzzy, I guess, of eBPF? Because as soon as I hear that there's something running in my kernel and somebody can replace it with anything at any time, does not give me a whole lot of warm and fuzzy.
So I think that's a good point. I think that part of it is trying to rationalize what's happening in eBPF. eBPF is different from two very different perspectives. One, when things like deep SDKs inside the code to perform observability, when they were new, like 12 years back, when solutions like, New Relic were born, that was also kind of, I wasn't sure about that as a developer, as an IT manager, because things are running inside my code and actually using up my application resources. They might jam my application, they might stall it, they might bottleneck it. We got used to that being okay, in a sense. Same thing for eBPF. I think that most R&D teams are used to running agents on their infrastructure for infrastructure monitoring for different reasons. eBPF is not going to feel different in that sense. And I think being backed up so nicely by such a vast community, it would make it even safer. For example, the eBPF verifier has gone a long way in the last couple of years. Eventually, it verifies that you can't load something that will create a bottleneck inside the kernel or access memory segments inside the kernel that can actually create a crash or a problem. So the community is actually also making sure that eBPF is going to be safe. And I think that from our experience, working with a lot of companies, that's not a main concern. They're more concerned about, resources and how much resources would it take to monitor or secure stuff using eBPF, which they would be also worried about using an SDK inside the code. But that's a fair concern. I think that safety and stability and reliability is something that is already fading away. And I think that as long as eBPF is going to continue evolving, it's going to be much less of a concern, because it's going to be such a commodity interface to the kernel that you're going to feel safe using it.
What do you say to people that are unwilling or unable to upgrade their kernels?
I think that we see it's kind of like cloud migration to Kubernetes, right? I mean, a lot of companies are in migration process to Kubernetes, and it takes time. As for big organizations, for big enterprises, it's not an easy transition. Same thing for kernel version. It's not like you get up in the morning and switch the kernel version on all the production. You clearly want to do it not just for eBPF reasons, but for 0-day patching and things like that. You want to keep your kernel version as much as fast as possible. For us, since we work in deep connection to Kubernetes, this is something that we encounter fairly rarely, because eventually the providers of the managed Kubernetes systems like GKE and EKS make sure that you run in the most advanced versions of the kernel, unless you specifically say otherwise. So we actually, in most cases, when we reach customers or try to help companies, they're not exactly aware what kernel version they're actually running inside their managed cluster. And they usually find out and see that it's a fairly new version. eBPF in its best performance has started around 2017. So probably if you're 5 years up to date, then you could use a lot of the capabilities that eBPF can offer today. So it's a fair amount of time. I mean, most companies are in that range if they're using Kubernetes.
What happens if I've got a Kubernetes cluster and I've got mixed node types? Right? It's not necessarily node types, but different kernel versions. And let's say also that I'm running a mixed OS. With eBPF, I cannot guarantee that it's going to run on all kernels, right? I mean, it's just not going to happen. So how would I even come about trying to mitigate that?
So there's two parts of that. One is kind of the kernel part of that, and the other one is the product kind of perspective of that, from, for example, the perspective of what groundcover is trying to do. So from the kernel level, you'll be safe. The kernel verifier has a way to reject BPF programs if they're using, for example, things that this kernel version is not aware of. So it wouldn't be loaded. It wouldn't create a weird state inside the kernel. It just wouldn't run. From a product perspective, and that's what we're trying to do, for example, in groundcover, we mitigate it to the customer using Kubernetes primitives. For example, they can define tolerations and limit us on specific nodes. We've worked with customers using Windows and Linux in the same cluster, using different kernel versions of the same cluster, using different CPUs architectures in the same clusters. So you can definitely use the different Kubernetes primitives that you're using today as a DevOps team to kind of define and say, okay, these nodes are out of reach for that daemon set that's going to deploy my BPF program. And that's the kind of the best way to manage it, not even getting to the point of you trying to execute on nodes that you're aware of that are out of reach. And we're trying to support all the Kubernetes native primitives around that to allow you to do that. So that's kind of the best way to mitigate it from a product perspective or an SRE team or DevOps team perspective.
You said earlier that at some point in probably the near future, we're going to be running eBPF whether we know it or not, due to the tooling, whether it's groundcover, whether it's fill in the blank. And I guess this is a variation of the question I asked earlier. What if I don't want that? How do you, as part of the community, as a vendor, convince me that it's as safe as it can be?
So I think everything in technology, all the major leaps in technology were not based just on, being sure that what you're doing is more safe than before. It has to be a trade-off between value and safety. I mean, for example, different features that we're using in modern world in communication and, collaboration between people, clearly that we gave our privacy along the way. I mean, we're aware of that and we're managing that trade-off. If, I want to talk to people and send them videos, I'm giving up privacy. So the same thing for eBPF and kind of performance around observability, for example, from our perspective as groundcover. Clearly, there's a trade-off. I mean, you might not want things to run inside the kernel for reasons that I think the community is mitigating and there's not really reason for concern. But even if you do, I believe that in the near future, the benefits are going to win that trade-off. Because eventually, if you want to monitor high throughput clusters, and you want to monitor hybrid environments where you're running different technologies, eBPF is going to open up the way to do it so much more easily that I think the benefits are going to win that trade-off. And even if you feel that you're kind of not know what this technology exactly is doing, if it's going to solve problems for you, you're going to be using it as a user. And I think the trade-off is a good thing. It should be, continuous tension between what the community is trying to provide as a value and where it holds back eBPF and make it more verified, more secure, more safe. And that tension is currently what's going on in this domain. I think that's kind of the best answer. It's never going to be a clean cut.
So you've talked about ground cover. Why don't you take a moment and give us the full pitch around ground cover? The floor's been yours the whole time, but the floor is yours.
So ground cover is basically trying to reinvent an APMs or application performance monitoring solutions for Kubernetes environments. And we do that on something which is kind of a twofold strategy. One is we're trying to solve the integration pain point of eventually integrating these solutions, these APM solutions into my environment or into my stack. Today, integration is based heavily on SDK, code changes, redeployments of applications to get things done in a microservices architecture where, there's sometimes more services than teams, more technologies than people. It becomes more and more hard. And we see teams taking months to integrate these solutions. And eventually only just this coordination inside the organization is a real pain. So for that, ground cover is using eBPF. As I said, we're installed as a daemon set. And it's kind of lights on in the cluster. You install a daemon set, which deploys BPF programs all around your nodes. And literally in 60 seconds, you get full observability, APM grade observability, as you would have expected from, long months of SDK integration into the code. The other part is eventually, as I said before, we're strong believers of eBPF. We contribute to the community. We push the open source community from our ability as ground cover. So we believe the eBPF is going to be a commodity in 2 or 3 years. You're going to be using it in many, many different aspects in production. But we think of it as another sensor to get data, interesting data from an observability standpoint into your observability stack. But something has to change also in the way APMs consume and digest this data. Teams today are really suffering from their ability to scale APM solutions. They cost too much. They store too much data for us to get insight as developers of what's going on. And ground cover also changes that. We're completely distributed, so we're not just using eBPF to pick up the data without any friction from the R&D team, but we're also integrating it really smartly in a distributed way inside each node. So we store and eventually kind of forces our customers to pay on much less data to get the insights that they need. And this is something that has been going on in the security industry for years. I mean, people couldn't have stored every file access, for example, to figure out if there's a security incident. You ran rule engines close to where the data is. We're bringing that to observability. So kind of these two together, eBPF, which is kind of a minute installation, and also be able to scale these things into high throughput clusters with, hundreds of nodes and be fairly, priced. That's a major change in how APM works. And these are the two pain points that ground cover tries to solve in a world which is pretty fine. I mean, APM is a great value. It's been here for more than a decade. We're trying to pitch it to the world very differently than what developers are used to consuming it.
So all of Shachar's information is going to be down in the show notes. But if people wanted to get in contact with you and they don't want to look at the show notes, what's the best way to get in contact?
So we have a community Slack where we talk directly to developers and answer questions. And we would love any feedback. You can reach it in groundcover.com. There's a link to our Slack. Feel free to join. Try out our free tier, which is a no time installation, and talk to us directly. We would love that.
Shachar, thanks for being with us today.
Thank you for having me.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.